Good day everyone, my name is Nyanbeni Mudau. I am a scientist production working for the Department of Agriculture and Rural Development in the Northwest Province. Today I'm here to share with you my research proposal, and the research topic reads as follows: Growth and yield response of Swiss Chard cultivars to harvesting frequencies under open field cultivation. Presentation outline. The presentation is going to cover the following aspect: introduction, motivation of the study, aim and objectives, materials and methods, expected output, and information dissemination. Introduction. The production of Swiss chard, often incorrectly referred as spinach, is popular within the smallholder farmers in the Northwest Province and is widely cultivated as a leafy vegetable, and production ranges from subsistence to commercial farming. Vegetable farmers in the province usually experience low yield and poor quality harvest due to lack of proper recommendation regarding harvesting frequencies. This will also depend on the kind of cultivar that a farmer chooses to plant during that growing season. The supply of several harvests indicates that the plant is able to regenerate leaves and shoot from one growing time, thus accumulating higher yield with less production area. The regeneration of leaves and shoots are mostly observed in the production of Swiss chard, where the crop can reproduce leaves when cutting level is above the lateral growing point. Common cultivars of Swiss chard grown in South Africa include Ford Hook, Giant, and Star 1801. Most Swiss chard cultivars are grown for 60 days after transplanting before the first harvest, while harvesting is done at an interval of 2 to 3 weeks. Incorrect harvesting frequencies can either lead to poor growth due to plant not getting enough time to recover, or a lot of unmarketable leaves that have overgrown due to lack of harvesting. To maximize the yield of Swiss chard among the smallholder farmers, this research will aim on identifying the correct combination of harvesting frequency and suitable cultivar that will result in higher yield and quality harvest. Aim and objective. The aim of this study is to improve Swiss chard productivity and management among the subsistence farmers in the Northwest Province, and the objective are to determine the yield of different Swiss chard cultivars obtained from different harvesting frequencies, and also to determine the interaction of harvesting frequency and different cultivars of Swiss chard on growth and yield. Motivation of the study. The use of outdated cultivars that results in poor and yield characterize the vegetable production practices among subsistence farmers in the province, and Swiss chard is not spared to this practice. To improve the vegetable production industry in the province, there is a need to make information available regarding the use of improved vegetable cultivar that can improve the production of Swiss chard and farmers' livelihood. Management of Swiss chard also involves harvesting or pruning of the crop that results in vigorous regrowth of the new leaves. This aspect of management, if not properly implemented, it may result in crop of poor growth that yield undesired output. Therefore, this research will provide necessary information regarding the correct combination of a cultivar and harvesting frequency that can improve the Swiss chard crop management for subsistence farmers in the province. Materials and methods. The trial will be implemented over 8 growing seasons during autumn and summer of each year over the period of 4 years, beginning in 2021 summer growing season, with a termination date of autumn season of 2026. The trial will be implemented in 3 localities: Taung, Khura and Mafikeng, and Potchefstroom Agricultural College. Soil samples will be taken for detailed analysis to determine nutrient content and fertilization requirement before planting in all experimental sites. The trial will be laid out as a split plot design using 5 varieties and 4 harvesting frequencies. The experiment will have 6 blocks of 4 main plots, each split into 5 subplots, wherein the main plot will be assigned to harvesting frequencies and subplot will be assigned to different Swiss Chard cultivars. The experiment will be consisted of 5 Swiss Chard cultivars. That is Fordhook Giant, which is called C1 for the purpose of this trial, Silverado C2, Bull's Blood C3, Star 1801 C4, and Eldorado, which is C5. And harvesting frequencies are as follows: harvesting once, which is our control; harvesting every after 7 days, which is H2; harvesting every after 14 days, which is H3; and harvesting every after 21 days, which is H4. All harvesting will commence 6 weeks after transplanting. There will be 20 treatment combinations for this trial, and these are going to be H1C1, H1C2, H1C3, H1C4, and H1C5, and then H2C1, H2C2, H2C3, H2C4, H2C5, and up until H4C5. Trial layout. This is how our trial is going to look like. We're going to have the 6 blocks. Then in each blocks we're going to have 4 main plot which represent the harvesting frequencies, and within the main plot we're going to have different cultivars, as you can look in our 6 blocks on your far right. Data collection. The following parameters are going to be measured: number of marketable leaves per plant, number of marketable leaves per plot, marketable fresh leaf mass per plot. Data analysis. Growth and yield data will be subjected to analysis of variance using a suitable program that is still going to be discussed with a biometrician. The mean comparison will be done using the least significant difference test. ANOVA table is still going to be discussed with the biometrician. Trial management. The land will be disked and harrowed before trial establishment. The seedlings of different Swiss Chard cultivars will be transplanted at 6 weeks at a spacing of 15 cm in a row and 30 centimeters between the rows. The gross plot will be 10.8 meter squares and the net plot will be 2.4 meter squares. That will give us the total number of 52 plants that we are going to measure for the data collection. The trial will be irrigated to field capacity through the use of drip irrigation. Weeding and will be done manually when the need arises. Insect pest and disease control will be achieved using the necessary registered chemicals when the need arises. Expected output. The results will help the small-scale farmers who are producing Swiss Chard in the province to use the correct combination of a Swiss Chard cultivar and harvesting frequency that can improve crop management, resulting in good quality yields. Dissemination of results. The results will be disseminated as follows. They are going to be disseminated through publications of articles, presentation in the local symposium, and presentation in local or provincial Farmers' Day. And with that, this is the end of the presentation. I would also like to take this opportunity and thank you all for listening to my presentation, and hopefully you find it interesting. Thank you.